today's lesson, we're going to be learning about using intercepts to solve equations and to graph lines. Just recently, we started working with what we call linear equations. Equations that, when you graph them, will produce a line on a coordinate plane. When we talk about the intercepts, it's almost like football, where somebody runs in between two people and intercepts the ball, takes the ball, passes through. The intercepts are where this line from the linear equation pass through the x-axis and the y-axis, and those points where they cut through the axes are the intercepts. Formally, here are the definitions that are from your book. The x-intercept is the x-coordinate of a point where a line crosses the x-axis. So basically, you know we have an ordered pair, an x and a y. So the x-intercept is the x that we have when y is 0, because if y is 0, the point stays on the x-axis. And likewise with the y-intercept, it's the y-coordinate in an ordered pair. The y-coordinate of a point where a line crosses the y-axis. And when we have a y-intercept, the x is 0. And what you'll be asked to do a lot over the next couple of days is to find the intercepts of the line. And this is what we do to find the intercepts. When we're looking for the x-intercept of a line, what we do is we take our equation, which will have an x and a y in it. It'll be with two variables. And what we do is to find the x-intercept, we substitute the y in the equation with a 0. And we simplify and solve for x, and that will give us our x-intercept. And then we follow a similar method when we're looking for the y-intercept. With the y-intercept, we take the same equation, only this time we substitute a 0 for the x, and then one step at a time, solve for y. And what we have here is a good example of a question you'll see very often over the next couple of days in class. Find the intercepts of the line 3x minus 2y equals 6, and then of course graph the line. Now, these are the steps we're going to follow one at a time. Hopefully these steps make the definition that we just saw much clearer. So you're going to follow these steps to find the x-intercept. I always go with the x first. First thing I do is I write the coordinate, which is the ordered pair. I put an x and then a 0. This reminds me of two things. Number one, I'm looking for x. And number two, I need to put a 0 in for the y. The next thing is to rewrite the equation, which I did over here, 3x plus 2y equals 6. Our third step is to substitute a 0 for the y. So we have 3x plus 2 times 0 equals 6. And we simplify. You know that 2 times 0 is 0, so 3x plus 0 equals 6. And remember, we're solving for x, so we have to do what we could probably do in our sleep by now. We divide both sides by the coefficient. Here the coefficient is 3, because now what we do have is a coefficient of 1, which leaves the x essentially by itself. And we learn that the value of x is 2. So the x-intercept for this line is 0.20. And now what we're going to do is follow these same steps to get the y-intercept. So we see the steps are exactly the same. The only difference is here. You see first, I copied my coordinates. So here we're making a 0. We're putting in a 0 for the x, and we're putting y in just for y. We rewrite the equation, and now what we do is we substitute a 0 for the x. So we have 3 times 0 plus 2y equals 6. Our next step is to simplify. 3 times 0 is 0, plus 2y equals 6. That gives us 2y equals 6. Our next step is to divide both sides by the coefficient. So we're going to divide both sides by 2. That gives us a 1y. And you can see that y equals 3. So our y-intercept is 0.03. Now, most of the time, we're done here when we're solving the equation, but notice I wrote a note to myself, and for you too, don't forget to graph the line. And here's what we do. Here I set up some graph paper. We have our 4 quadrants, and just to make it easier, I label the points that we are going to have to graph. We need point 2, 0, so we're going to move over 2, and since the y is 0, we stay right here, so my point is on the x-axis, that's why it's the x-intercept, and the y-intercept is at point 0, -3. Negative means we go below the origin, so we have 0, 1, 2, 3, and of course we use a ruler because we always have to connect our dots. Since this is a line and lines go on into infinity, don't forget your arrows at the end of each line. So this is a graph of the equation 2x plus 3y equals 6. So I'm sorry, 3x plus 2y equals 6. Okay, now our second example is just like the first, but I know how students react when they see fractions in an equation. But I want you to know that the method is the same even when you're using fractions. So we have our equation, -1/3 x plus 7/6 y equals a -7/3. Doesn't look very friendly, but we're going to follow the same steps, and you'll see it's not very hard to do. So we're solving for our x-intercept first. So I write the coordinate x, 0, and then what I did was I followed our second step. I rewrote the equation, and our third step, if you remember, is to now substitute a y, the y with the 0. So we have -1/3 x plus 7/6 times 0 equals a -7/3. Our next step is to simplify. So we have a -1/3 x plus 0 equals a -7/3. And now you know that we have to isolate the variable. We want the x by itself. Just to remind you that when the coefficient of the x, or any variable for that matter, is a fraction, the way to get rid of it is to, well, you know you're dividing, so you have to divide both sides by a -1/3. And you know that when you're dividing by a fraction, you actually have to multiply it by its reciprocal. So what we do right away, just to save some time, is I'm going to write the reciprocal of a -1/3, which is a -3/1. We'll multiply that by the 1/3 x. And remember, because it's an equation, what we do to one side, we have to do to the other. So we're going to take our -7/3 and multiply that by -3/1. Then what we can do is we cross-simplify, and we end up with 1x. We can cross-simplify, the 3's cancel each other out. Negative times a negative is positive, and we find that x equals 7. So our x-intercept is 0.70. We're going to do the same exact thing on the y-intercept side. I've already written the coordinate and rewritten the equation. Our next step is to now substitute the x with a 0. So we have -1/3 times 0 plus 7/6 y equals -7/3. We end up with 0 plus 7/6 y equals -7/3. And just as we did over here, we're going to multiply both sides by the reciprocal of the coefficient. So we're just taking the fraction and flipping it. What that means is we're going to multiply both sides by 6/7. When we do, these cancel each other out. We get a y equals. Here the 7s cross-simplify to 1s. The 3 goes into itself once, it goes into 6 twice. So here y equals 2, and the y-intercept is 0, 2. So except for that added step of multiplying by the reciprocal, dealing with fractions is exactly the same way. Decimals too. Now, example 3. Example 3 is reflective of problems you will encounter a lot over the next couple of days. Very, very wordy, because they're telling you a story and they're giving you a lot of directions. Just in case you can't see it, I'll read it to you. Your dog needs to eat 800 calories of food every day. Its wet food has 40 calories for each ounce, and the dry food has 100 calories for each ounce. We have to do 3 different things. First, in part A, we have to write an equation that tells the possible amounts of wet and dry food that you can feed to your dog each day. B, use intercepts to graph the equation. And then C, give 3 possible combinations of wet and dry food that you can feed your dog every day. Wow, that is a lot. But I'm sure I will break it down in such a way that you'll feel that this is very manageable. So the first thing we need to do is we need to come up with an equation, an x and a y equaling some number. And for this problem, I just wrote this down. This is how I attack these problems. I write down what I know. We know that we can feed our dog wet food that has 40 calories an ounce, and I'm going to call that x. And my y is going to be the dry food, which is 100 calories per ounce. Now we know that our dog can eat a total of 800 calories. That's where I start, equaling 800. Whatever combination of the x and the y has to be exactly 800 calories. So how do we put together the rest of the equation? Well, as I said, I'm calling our wet food x, and we know that the wet food has 40 calories for every ounce. And we're going to add that to 100 calories for every ounce of dry food. And when you put that combination together, we get a total of 800 calories. So if you just go through the story and the word problem one piece at a time and write down the information that you know, then you can start to piece together your equation. And now what we're going to do is follow the steps that we learned in examples 1 and 2 to find the intercepts. So just a reminder, when we're looking for our x-intercept, it means our y is 0. So I wrote my coordinate. Our next step is to rewrite the problem. 40x plus 100y equals 800. Our next step is to substitute the y with a 0. So our 40x stays the same. 100 times 0, and this equals 800. Our next step is to simplify. So our 40x still doesn't change. Now what we have is 40x equals 800. We divide both sides by the coefficient 40. And we know that x equals 20. What does this mean? It means that if we fed our dog only wet food, then he can have 20 ounces and no more, no less. So on our line, our x-intercept is 20, 0. And now we're going to do the same thing to solve for the y-intercept. We will rewrite our equation. And this time we're going to substitute the x with 0. We simplify. Next, we divide both sides by the coefficient 100. And we learn that if we fed our dog only dry food, then he could only have 8 ounces. That's not a lot of food. But we know our Y-intercept is 0.8. Next part is to graph the line. Now this graph is different from the graph that we completed in part A, and in example 1, pardon me, and there's a reason for that. When we have a real-life application for a pre-algebra skill that we're learning, so that means we learn something in math and we use it in our real life, we have to make the graph to fit our needs. Now this graph is only in the first quadrant of our coordinate plane, which means that both our x-axis and our y-axis have positive numbers. And the reason I chose this is that we're talking about feeding a dog dog food. You would never give your dog a negative amount of food. That's why we stick with just the positive coordinate. So what we do is, if you remember, our x-intercept was at 20, 0. So from the origin, we move over 20. And we don't go up at all because our y is 0 and it lands right on the x-axis. And our y-intercept is 0.8, which is here. And then we connect our dots to make a line. And that takes care of part B. Now, if you remember back to the problem, part C asks, what are 3 different combinations of food that you can give to your dog? Well, we already know that your dog can have either just 8 ounces of the dry food or just 20 ounces of the wet food, but we can combine. Basically, any number that falls on this line is a solution to that equation. So if we looked over here at this point, this is point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. What this is saying is that we could give our dog 5 ounces of wet food and 6 ounces of dry food, and together they would make 800 calories. So when you're asked to give different combinations of whatever it is you're looking for, it just means pick any 3 points that are on the line. Now our last example is similar to number 3 in that it is quite involved. But that doesn't mean it's unmanageable. Here. In example 4, what we have is a geometry problem, but not area, which is what we're typically asked for. This has to do with perimeter. A rectangle has a perimeter of 16 inches, and again, we have 3 things that we have to do. In part A, we have to write an equation describing the possible measurements of the length and the width that would give us a perimeter of 16 inches. Part B, we have to use intercepts to graph the equation. And then in part C, give any 3 pairs of lengths and widths. So in part A, I started us off by reminding us of what the formula is for perimeter. Perimeter equals twice the length plus twice the width when we're talking about a rectangle. Because you know perimeter, peri, means around. Meter comes from the word measure. When we talk about perimeter, we mean the measurement around the rectangle. Now for this problem specifically, instead of writing P for perimeter, we are going to insert 16 because we know that that's what the perimeter is. We don't know the length yet, nor do we know the width. So this is our equation. This satisfies part A. Now part B, use intercepts to graph the equation. So we're looking for the x-intercept, which is point x0, and we need the y-intercept, which is 0.0y. So we rewrite the equation. 16 equals 2L plus 2W. Notice we have a difference here than what we've been doing. All along we've been working with just x's and y's. Here, as you can see, because it comes first, L is representing our x. So I'm doing that purposely just to help you to recognize that sometimes we have to look at a problem a little differently but still manage to see what we have learned. So all we're doing is taking the x and calling it length. So if x is our length, that means our width is our y. So to find our x-intercept, it means what we're doing is we have to give our y, our width, the value of 0. And when we do that, we find that 16 equals 2L plus 0. 16 equals 2L. We divide both sides by the coefficient 2. And here we learn that our length is 8 inches. So our x-intercept is 0.80. Now, of course, you'll be able to recognize already that our y-intercept will also be an 8, only this time 0.8, because when we go through the steps, because both the L and the W have the same exact coefficient, we will end up with the same answer, but I'll go through the steps anyway. Our perimeter of 16, but this time we are substituting our x, which is our length, with 0. We get 16 equals 0 plus 2W. And here's what I mean. We end up a second time with 16 equals 2W. We multiply both sides by 2, and we learn that our width could be 8 inches. And then to finish off part B, we have to graph. Again, just as with our dog food example, this is a real-life application. So we are using only the positive quadrant to graph our points. This time I labeled our x-axis as our length and our y with our width in inches. Both, so our x-intercept was at 8,0, and our y-intercept was a 0.8. We connect these dots. And so when we're asked for 3 different combinations of lengths and widths to give us a perimeter of 16 in a rectangle, we would just pick any 3 points that are on this line. So this lesson had a lot of information in it, a lot of writing, a lot to think about, a lot of reading, but I know that if you pay attention, you'll be able to follow this and you'll do this with ease.